Hi, boys and girls. Today we're going to be starting section 2.4, solving equations with variables on both sides. Okay, I've actually broken this up into two separate parts because there's a lot in it, and I think we need to go through it slowly. It's also very important information. So if you turn to your workbooks on page 91, all right, we have our goals, our vocabulary, and an introduction explaining to you that when you have an equation with variables on both sides, your first goal is to get all your variables on one side so that we can solve for the variable. Okay, we do that by adding and subtracting to both sides. In the past, you've added and subtracted numbers to both sides, but in this section, you're going to find that you can also add and subtract variable terms from both sides. All right, here's example 1. You'll notice on the left there's a 7a and on the right there's a 4a. All right, so our first goal is always to get all of our variables on one side. Don't even think about 5 and 13 for right now. We don't really even know for sure which one we want to get rid of. What we do need to do is get these variables on one side. Now, which one do we target? Do we target 7a or 4a? I always tell my students it's usually easiest to target the smaller variable. In some cases, this will help keep you from ending up with a negative variable at the end. And so generally that would be the plan, would be to go after the smaller variable. The only time you wouldn't want to do that is if the small variable is the only thing on its side. And I'll show you several examples and that will become clearer. So here we would target the 4a because it's smaller. Okay, so what they do, let me fire up my electronic writing device. What they've done is they are going to get rid of this 4a. It's a positive 4a, and the way we get rid of that is by subtracting 4a from both sides of the equation. Now, of course, we can't subtract 4a from a 5. We're subtracting this 4a from the 7a. 7a minus 4a is 3a. And this 4a and that 4a cancel each other out, and all that's left on this side is a negative 13. Okay? So now we have 5 plus 3a equals negative 13. Now it's clear to see what number we want to get rid of, what constant we want to eliminate. We want to eliminate the 5 so that we can get our variable term by itself. So we subtract 5 from both sides. Then we have 3a, and negative 13 minus 5 is negative 18. So we have 3a equals negative 18. Our final step then is to divide both sides by 3 to get a by itself, and we find that a is equal to negative 6. Okay. Down here in the check, what they have done is they've taken the original equation, and where both of the a's were, they have replaced them with the negative 6 that we found to be the solution. Then they checked it, they multiplied these two, and then we added and we subtracted, and we get a true statement. Negative 37 equals negative 37. That tells us that our solution is correct. Here is an example about a hot dog eating contest, and this is legit. There is a hot dog eating contest every year sponsored by Nathan's Hot Dogs. If you've never had Nathan's Hot Dogs, they're excellent. They're my husband and my son's favorite. The results of the 2015 Nathan's Hot Dog eating contest are shown. So we have a man, Matt Stoney. He ate 62 hot dogs in 10 minutes, and Mickey Sudo ate 38 hot dogs in 10 minutes. My mom claims to have eaten about 30 hot dogs one time, but I don't think it was that many. I think originally it was maybe 10 hot dogs, and then over the years it got to be more. Okay, suppose the men and women's winners, Matt and Mickey, decide to compete against each other. To make the competition more interesting, Matt will not start until Mickey has eaten 20 hot dogs. Assume that Matt and Mickey eat at a constant rate throughout the competition. Based on the number of hot dogs eaten in 10 minutes by Matt and Mickey, how many minutes after Matt starts eating will they have eaten the same number of hot dogs? These little blanks over here were just too small for me to try to write in, so I've kind of filled them out ahead of time. Matt eats 62 hot dogs in 10 minutes. I got this from the chart, okay? And I know it's a 10-minute contest because it says it down here. Now, that is a rate of how many hot dogs per minute? It's just 62 divided by 10, okay? So the number of hot dogs he has eaten in m minutes, so he eats 6.2 hot dogs every minute. So this would be 6.2 times the number of minutes he's eating hot dogs. We do the same for Mickey. She can eat 38 hot dogs in 10 minutes, which is a rate of 3.8 hot dogs per minute, If she's given a 20 hot dog head start, then her equation is 3.8 m for her 3.8 hot dogs per minute plus the 20 she got for the head start. So the equation 6.2 m equals 3.8 m plus 20 represents the point at which they will have eaten the same amount of hot dogs. Whatever m is, that's the point in the contest where they will have eaten the same number of hot dogs. So further down on the page, it asks you to solve the problem, all right? Now here, we're going to want to get rid of this 3.8 m, okay? So we subtract 3.8 m from both sides. All right, I went up to the smaller one, okay? 6.2 m minus 3.8 m is 2.4 m, and this number here and this number here cancel each other out, so we just have 20 on the right-hand side. Our last step would be to divide both sides by the coefficient of the variable, the number in front of the letter, which is 2.4, all right? And I believe I've had this one figured out ahead of time. Is it 8.3 or something? I think it's 8. Yeah, it's 8.3. I did figure it out ahead of time. All right. So that means that at 8.3 minutes, the two of them will have eaten the same number of hot dogs. Okay. All right, here we have a basketball word problem. I love how they launch right into word problems with these. Nolan and Victor were two of the top scoring freshman players in a college basketball conference last season. The table shows how many points Nolan and Victor scored and how many games they played last season. The points Nolan and Victor scored this season will be combined with their points from last season to give their total career points. This season, Nolan is hoping to catch up to Victor and have the same number of career points. Assume that Nolan and Victor play every game and score at the same constant rate as last season. So here we have our table. We have Nolan played 30 games and scored 750 points. Victor played 34 games and scored 782 points. All right, so what we really need to know is how many points they're scoring per game, their average points per game. If we do 750 divided by 30, we find that Nolan scores 25 points per game on average. We do 782 divided by 34, we find that Victor scores 23 points per game, okay? So if we were going to solve this, then it's not even all on the screen, is it? Let me move it over. Okay, there we go. If we were going to solve this, we want to know at what point will they have the same number of points, okay? So to solve this equation, the first thing we do is we want to get all of our variables on one side. So we have 25p here and 23p here. 23p is smaller, so there's no reason for us to not go ahead and eliminate the smaller one. So subtract 23p from both sides. That gives me 2p plus 750 equals 782, because these are gone now. Now my next step would be to get the variable term by itself. So I subtract 750 from both sides. Oh, I started with 50. All right. And that gives me 2p equals 32. Then we divide both sides by 2 to get p equals 16. Hang on a second while I go answer the phone. Sorry for that interruption. Makes you feel like you're in school for real, right? The phone's ringing all the time. All right, so, okay, so based on our equation and our math, how many games this season will Nolan and Victor have scored the same number of career points? At the 16 game point. Okay, all right, next example. Okay, so now we're going to talk about the distributive property. Okay, this is something you probably learned last year, but I'll go slow just in case you didn't get to spend a lot of time on it. All right, last year got cut short. Sometimes the equations that we're solving are going to have the distributive property in them. If we have an equation with parentheses in it, we have to get rid of that first. Even PEMDAS tells us that. Parentheses got to go, okay? So if we have an equation with parentheses, we do that first. Then we simplify. Once we do the distributive property, then we simplify. We combine like terms if we can. Then we get all of our variables on one side. All right, and that's what these steps are telling you. So let's look at an example. All right, here we have distributive property on both sides, okay? Now, like I was saying, if you're rusting on the distributive property, or maybe you weren't there that day, here's what we do for the distributive property. I don't see any difference between the first line and the second line. So here on the second line, what you do is this number outside the parentheses gets multiplied or distributed to everything inside the parentheses. So this would be 7 times n, or 7n. Then we have to go back and say 7 times -1 gives us -7. Or you could be thinking 7 times a -1 gives us a -7. Okay? Remember, the sign in front of the number always goes with the number. Over here, we have a -2. This would be -2 times 3, which is -6. Oh, my handwriting. And then we would go -2 times n gives us -2n. Okay? Now in this next step, we're trying to get all of our variables on one side. -2n is smaller than 7n, so that's the one I'm going to target for elimination. And the way you get rid of a negative or a -2n is you add 2n to both sides. So add 2n to both sides. All right. On the left-hand side, we can combine the terms 7n and 2n. It's positive 7n, positive 2n, which gives us positive 9n. And then we have the -7. Which can't be combined with n's. On the right, we have a -2n and a positive 2n. Those wipe each other out. That was the plan. And we're left with just -6. Now it's just a two-step equation. We want to isolate the variable term, so we need to get rid of this -7. We do that by adding 7 to both sides. Okay. Now, these two cancel out. I have 9n left on the left side, and on the right, -6 plus 7 is 1. My final step is to divide both sides by 9, and I get n equals 1/9. Isn't that fun? I love solving multi-step equations. It's pretty much my favorite thing. Okay, so here's our check. All right, we're going to do this again. First thing we have to do is get rid of parentheses. So 7 times n is 7n. 7 times -2 is -14. Ooh, and look, they put in an extra term. We have +8. We're going to have to combine like terms now. 3 times n is 3n. And 3 times -4 is -12. And then we have a -2. All right, and like I said before, sometimes after you distribute, it's necessary for you to combine like terms. You can only combine like terms if they're on the same side of the equal sign. I can't combine the 14, the 8 with the 12 and the 2. They're on different sides. We can't just combine those. I can, however, combine a -14 with a +8. So that would give me -6 or -6, a -14 plus 8. And over here, I have my 3n, and I have -12 minus 2 is -14. Okay. Now I'm ready to progress to the step where I want to get all my variables on one side. So now I'm going to target the smaller of the two variables, which is 3n. I'm going to subtract 3n from both sides. Oh, here I go trying to draw a line again. That's always an adventure. 7n minus 3n is 4n minus 6. Bring that down. And on the right-hand side, that's gone, and I'm left with just -14. My next step now is just a two-step equation. I want to get the variable term alone, so I need to get rid of a -6 or a -6. I can do that by adding 6 to both sides, which gives me 4n equals -8. Yep. And then I divide both sides by 4, and I come to the conclusion that n is equal to -2. Yeah, that's fun. There's a lot in this section, so that's why I broke it up into two. This is just half of it. Okay, so now they want to introduce you to solving an equation when it has a fraction bar. Okay, there are lots of ways to complicate equations, and this is one of them. Just like in the two-step equations, when you have a big hideous fraction like this, your first step has to be to get rid of this fraction thing. We have to free the 12y plus 16 from the numerator. The way we do that is we multiply both sides by 4, and this fraction ceases to exist. So over here, we're going to multiply by 4, going to multiply this side by 4. And what happens is these cancel, and all we're left with on the right now is the 12y plus 16. On the left, we did 4 times 5y is 20y. Now we have 20y and 12y. I want to get rid of the smaller variable, so I'm going to subtract 12y from both sides. And that gives me 8y on the left. On the right, these cancel out as planned, and I have 16. My final step then is to divide both sides by 8, and I get y is 2. Hang on, there's more fun to come. Okay, I have given this problem the worst example ever award, okay? And I will tell you why. It's not so much the problem itself, it's the way they solved it. And I would have just wiped it all out and solved it correctly, but this is printed in your book, so you would have seen it and said, why is Miss Williamson doing it differently? And I'll explain to you in a minute what I don't like about it. It says, find the value of x so that the figures have the exact same area. Okay, well, you need to know area formulas. The area of a rectangle is length times width. The area of a triangle is 1/2 the base times the height. 1/2 times base times height. Well, so the equation for this is to get the area of the rectangle and set it equal to the area of the triangle, all right, and then solve for x. So down here, they've given you some gobbledygook, and it says the equation, to find the area of this rectangle, we have to multiply 5 times x plus 4. So the x plus 4 has got to go in parentheses because it's not just 5 times x, it's 5 times the whole thing. So we put the x plus 4 in parentheses. Now on the right, the area of a triangle is 1/2 times the base, which is 12, times the height, which is 2x plus 6, in parentheses again. Then we come down here to solve it. Okay, so far so good. All right, it's not the worst problem ever yet. Well, but the first thing we have to do is just, well, they multiply the 1/2 times the 12. Okay, so then you get 1/2 of 12 is 6. Now we have to use our distributive property. 5 times x is 5x. 5 times 4 is 20. On the right, 6 times 2x is 12x. And 6 times -6 is -36. Here's where it goes wrong. They decide to go ahead and add 36 to both sides before they got all the variables on one side. No, 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 no. That is not how you do it. That is the dumbest thing I've ever heard. They just got done telling you that you had to get rid of your variables first. And then they have this example where they do the dumbest possible thing ever. So, I went ahead and I showed this is what they wanted me to do, add 36 to each side, but you still have variables on both sides. And now the second step, they have you get rid of the 5x. That's the dumbest thing ever. That is not how you solve that problem. I'm having more trouble with this reveal this year. The first thing you have to do when we're here is ask yourself which variable is smaller and get rid of it. 5x is smaller than 12x, so I subtract 5x from both sides. I mean, I'm going to arrive at the same solution, but over here, they just, guessed they were going to get rid of the 36? How do you know which one you're going to get rid of? You got to get your variables on one side first. Now we have 20 equals 7x minus 6. Now I know the 6 is what I need to get rid of, okay? So I'm going to add 6 to both sides. What did I do wrong? I did something wrong. Did I write this down wrong? 5x plus 20. Oh, I did. This was 36. I could tell this was going horribly wrong. They just got me so riled up. So this is 36. It's like, what? It's not working out. It's 36. Okay. And so we're going to add 36 to both sides. Sorry for the messiness. Now I have 56 equals 7x. And when the very little space we have left, we divide both sides by 7, and we get x equals 8. Okay? So if x is 8, the rectangle and the triangle will have the same area. Oh, just, put a Post-it note over this example. Just forget it ever happened. Worst example ever. Here's a better one. Okay, so here's your chance to do this. Find the value of x so that the figures have the same area. You might want to pause the video and see if you can do it yourself. What I would do though is with this side here, you'll notice that this is 3 centimeters and then X centimeters extra. This side is really 3 plus X, okay? So if you're going to pause the video and do it yourself, make this side be 3 plus X, all right? If you did pause the video and you're back, welcome back. Here we go. All right, the area of the rectangle is 10 times X, or length times width. The area of this rectangle is length times width also. We have this side is 6 and this side is 3 plus X, so we're multiplying them together. Now, the first thing we have to do is get rid of those parentheses. 6 times 3 is 18. 6 times positive X is positive 6X. Now, it's usually best to get rid of the smaller variable, so 6X is smaller than 10X, so we'll subtract 6X from both sides. And that gives us 4X equals 18. Right? And then we divide both sides by 4. Right? And that gives us X equals 9 halves, or 4.5, or 4.5 for you decimal lovers. Kind of messy. Sorry. That's how you do that one. And that brings us to the end of part 1, okay? I know you're really excited to see what's in part 2. What fun times. And when you come to class on Monday, we will do the examples in the practice problems that go with this section, or this first part of the section, okay? And then we'll do the second part of the section. It's going to be a fun couple of weeks. It really will. All right. I hope you enjoyed this video. If you did, go ahead and watch it again. Just kidding. You probably don't want to watch it again. All right. Love you guys. See you in class.